All right, how am I going to start our warm-up today? This is from last chapter. Ideas? Subtract 5, great. So x is greater than 4. To graph that, I need a number line. Start at the 4. Is this going to be an open circle or a closed circle? Open, and then things that are greater than 4 are to the right, so I shade in the right of the number line. Questions? What about the next one? Divide by -3. Good. And flip the sign. Great. To graph this one, I have -5, 5. Open or closed? Closed. And right or left? Right. Good. What are your questions? Now, our lesson today is very similar to this, except we will have 2 variables on most of them, and our graphs won't be on number lines, they'll be on the coordinate plane. Okay? So you will need graph paper for today's lesson. You will need to remember the things we learned about underlined, not underlined, closed, open, but we will go from there when we see the examples. Any questions on the warm-up? Yes, you will need graph paper. Go get some. Yes, it's right up in that bin. Here's our section number for today. We are doing section 2.6. It's all about linear inequalities with 2 variables. So before we actually start graphing these, we're just going to talk about checking solutions for inequalities. So here's our first example. So x is greater than or equal to -1. That's our inequality. And then these are the 2 points we want to check. When you are checking to see if something is a solution, you are plugging in the x value where you see an x, the y value where you see a y, and then seeing if the statement is true. This inequality actually doesn't have any y's, so we're only going to be plugging in the x values. So to check the first one, I am just going to rewrite it. I'm going to replace the x with a -1. Now you have to ask yourself, is this a true statement or a false statement? -1 is greater than or equal to -1. True. So it's a solution. Let's check the second one. So again, I'm only plugging the x value in because there's only an x. 5 is greater than or equal to -1. Is that true? Yes. Yes, so this is also a solution. What are your questions on this first example? Here's our second example. This one's a little different because now we do have x's and y's, so we can plug them both in. So y is less than or equal to x plus 1. We're going to first plug in 4 for x, 5 for y, and then check to see what happens. We can add these two. 4 plus 1 is 5. So 5 is less than or equal to 5. True or false? True, right? Because it's an or equal to. So that is a solution. Now we can move to our second ordered pair. So I'm going to rewrite my inequality. I'm going to replace x with -2, y with +1. See what happens. Simplify the right. -2 plus 1 is -1. Is 1 less than or equal to -1? No. So when it's false, it's not a solution. What are your questions on this? Here's example 3. This is similar to an example we looked at already, example 1. Because there aren't x's and y's, there's only y's. So really we can only plug in the 6, and then we'll plug in the 2. So for my first one, 6 is greater than 5. True. Two is greater than 5. No, not a solution. So these aren't super challenging as long as you're plugging in x's and y's into the right spot, simplifying, and then just check to see if you get a true statement or a false statement. True statements mean it is a solution. A false statements mean it is not a solution. Questions? Here's example 4. 4x less than -9. Again, there's only one variable here, so I can only plug the 3 in and then the -2. when I plug the 3 in, 12 is less than negative 9. No, not a solution. Plug the negative 2 in. Negative 8 is less than negative 9. Also no. So both not solutions. Very good. What if it said, give me an x value that is a solution? What would you say? Negative 11. Yeah. Anything basically, maybe like a negative 3, right? That would give us negative 12. That would work. Yeah, so, yeah, very good way to state it. Good. So he said as long as it's less than negative 3 when you plug it in, it will work out. Great. What are your questions on this? All right, now we're going to look at the graphs. These get a little trickier. So here's our first one. 2x greater than or equal to negative 4. The first thing you want to do is get it into a form that we can graph. So if there's a y value, get it into y equals mx plus b. If there's only x values, like on this one, just get x by itself. So to get x by itself, I would divide both sides by 2. I would get x is greater than or equal to negative 2. Now, this is one we could graph on a number line. However, all the graphs today are going to be on the coordinate plane. It's basically the same idea. It's just a little bit different. So, if this was on a number line, would we use an open circle or a closed circle? Closed. So, it's the same thing. If it's an or equal to, we use a solid line. Because it's a graph, so we're graphing lines. If it would be an open circle, we would use a dashed line. So same general idea, except now we're doing lines. So it's kind of like an open or a closed line. They're either solid or they're dashed. Now we have to decide which way to shade. There's really 2 ways to decide which way to shade. I usually look at the sign and I think of what values would make it true. So which x values would be greater than negative 2, one's to the right or one's to the left?
To the right.
To the right, good. The other way to do it is to do a test point. So you can test a point by plugging it in just like we were doing. If the test point makes it true, you shade in the area where the test point was located. So this test point was right here, so we would shade that whole region. Or just think, where is the x value is going to be greater than negative 2? It's also to the right. So either way you want to figure out the shading is fine. We'll discuss it on each example, how you could process through it. But the test point method always works. Some students like to do that every time. What are your questions on this? Example 6 is similar to example 5, where we're only looking at one variable equations. Some people find these to be the easy ones. Some people find these to be the hard ones. It just kind of depends on your preference. Before we graph it, though, we need y by itself. So what do I need to do? Divide by negative 1. Good. When you divide by negative 1, you flip the symbol. So now it's y greater than 2. Again, we're putting these all on coordinate planes. It is not an or equal to, so when you graph this, you are just going to use a dotted line. So it's a horizontal line. It is an open line, if you want to think of it that way, so it is dotted. The dotted line means that points on this line are not solutions, because they would be or equal to. So if it is or equal to, that's when we use the solid line to show they are solutions. Here they would not be solutions, so we use the dotted line. Now, you can either think to yourself, where would the y values be greater than 2? Above or below? Above. That's one way to think of it. Or you can do a test point. We're going to test 0, 0 here. If you plug 0 in, 0 is greater than 2. So would that region get shaded? No, it'd be the opposite region. So test point's great, or you can kind of reason through it on your own. Either way, you should end up with this as your graph. What are your questions? All right, before I can look at my graph, I need to get the x by itself. So what do I need to do?
Divide by 3.
Divide by 3. Great. So I come up with x less than or equal to 3. So is this going to be a solid line?
Yes.
Yes, because it is an or equal to. X equals our vertical. So at x equals 3, I'm going to draw a vertical line. It's going to be solid. Again, you can reason through it to decide where to shade. You can do a test point. Where do you guys think we'll shade, left or right? Left, because that's where they're smaller. A really good test point is always 0, 0. It's quick. It is true in this case. So that just verifies for us that we are going to shade to the left. All right. How am I going to graph this?
You do y mx plus b.
Yeah, it's y equals mx plus b. So Tyler, where would I start?
Your y-intercept's at 2.
Yeah, we're going to start with our point, our y-intercept at 2. The slope here is -1, so I'm going to go down 1, right 1. Down 1, right 1. You can do it as many times as you want. Usually 3 is a good number. Some people like 5. It just kind of depends on who you are. This is going to be a solid line because it is an or equal to. Now the fun part. Are we going to shade up or down?
Down.
Let's see. If this was me, I would reason through it by looking at this sign. I would think, where are the y values greater than the line I just drew? Well, the y values would be greater up, right? Some people don't like to reason through that way, and that's fine. Those people would use a test point. If 0, 0 doesn't fall on the line, I would always use it as a test point. It's super easy. You would get 0 is greater than or equal to 2. That's not true. So you will not be able to shade in the region that includes the 0, 0. You'd have to shade in the other region. The other region for that reason. Sorry. Getting tongue-tied. Or again, like I said, you could just think, where are the y values going to be greater than the line? Y values are bigger as you go up, so we're going to shade above. What are your questions? All right, here's number 9. Again, this is a pretty simple one to graph because y is already by itself. So we are going to start at 4. Very good. Now, the slope is -1 over 2. So what am I going to do?
Go down 1, right 2.
Down 1, right 2. Down 1, right 2. Now, before you draw the line in, you have to decide what kind of line is it going to be. Dash, good. Because it's not or equal to, dashed or dotted. Either way, as long as it's not a complete line. Now, reason through or test a point. I will do both. Reasoning through, where would the y values be less than this line? Below, right? All of these y values are going to be less than that line. Or we can test a point. The test point is in the region that we think we should shade, so it should make it true. It does. So shade down. You could actually use the reasoning and then use the test point to check. It's kind of up to you. What are your questions? Is number 10 ready to go?
Yeah.
No. Why not?
Because it's -y.
Yeah, y is not by itself. It's almost by itself. It's not quite by itself. So what do I need to do?
Divide by...
Yeah, divide everything by -1. Essentially what that does, it changes all your signs. So now the x that was positive is negative. The +3 is now a -3. And anytime you multiply or divide by a negative, you flip the inequality symbol, just like we had to do on our warm-up. So be aware of that. That is still a rule here. Now, we graph. Where am I going to start? -3. Slope is -1, so down 1, right 1, down 1, right 1. Solid line or dashed line or dotted line, however you want to say it. Solid, good, because this is an or equal to line. Now, if you're going to reason through like I've been doing, look at this one. Look at the one you actually graphed. So where would the y values be greater than this line? Up or down? Up. Good. Or you could always use a test point. When you use a test point, you can plug it into either equation. It should either hold true for both or be false for both. This one is true, which just proves that we were shading in the right spot when we said shade up. What are your questions on these graphs? All right, if you are ready to go, here's your homework. It's all odds. Make sure you're checking your answers in the back of the book, and let me know if you guys have any questions.